Hey guys, before we get into this video, you'll notice that only a few people are subscribed to my channel. So most people who actually watch my content aren't subscribed. So if you do me a huge favor, please subscribe before you get into this video, and I'd really appreciate that. Welcome to Khetz Tutorials, and in this video, I will be starting a series on finance. So this is the first video, and it involves a bit of revision and some other things which are quite important. So let's get right into it. I'm going to start with this series of formulas, or I'm going to start with just a few formulas for you. And let's start with simple interest. Simple interest. And this is a formula which I expect you to know, and it's basically used when it's explicitly stated that a certain value increases linearly, or it increases according to this simple interest fashion. And as it increases, you'd have your principal amount. In terms of finance, you'd have your principal amount, which is the amount which, let's say, you put into an investment, and it's going to be multiplied by what's inside the bracket, where your I would be your interest rate, and your N would be your number of years. And this A over here would be your accumulated amount, which is basically the amount which you get after having this type of growth over there, right? So this is the simple interest formula, and I'll show you how to use it in just a bit. Another formula which follows a linear fashion. By a linear fashion, I'm basically saying there aren't any exponents, and you can actually get a ratio or something like that linearly. In the same fashion that we go up, so this is to find, in the first one over here is to find a new value. So A, to find a new value A, which is accumulated, which is found over time after multiplying the number of periods or the number of years by the interest, and adding that to your original value, which is your principal, right? We can also go in the negative direction and actually decrease a principal amount or a certain value which we have, and that would be called your straight line method, or your simple decay. Simple decay indicated or shown by the following formula. So basically it's the same formula, just that now we subtract the effect of the years on the interest rate. So everything is basically the same. A is your accumulated value, P is your principal amount, and I would be your interest, and would be your number of years. And that is all for this simple part. We can now talk about compound interest. So moving on to compound interest, this is where we involve exponents, and that is where the term compound or compounding, the action of compounding, comes from. Now that same bracket which you had for simple interest, so we had A equals to P1 plus I. This bracket is now like this, and the number of periods or the number of years in our case, for this very simple example, or this simple case, we have N being the exponent of this whole bracket over here. And that is your formula for your compound interest. You'll be told that a certain thing grows according to the compound interest fashion, or it is compounded. There will always be hints that will show you what to use and basically what to use. And just as we did with the simple interest, you can basically do the same by going the negative direction. So just swap the sign, and you have something called, let's say, reducing balance. So when the question talks about reducing balance, just know it is talking about this depreciation in a compound fashion. So A would be P multiplied by 1 subtract I to the power n. And everything is still the same, just that the application and the placement of all the variables is quite different. And I'm just going to move on to examples. So just have these formulas at the back of your mind, and I'm going to move on to examples so that we actually see these things in play and see how you can actually use these formulas. But before we do that, I just want to look at two more things which are interesting or which you should know. And the first being, so if you come to this formula, let's come to this formula on this side. If you come to this formula, let's say you have your A, you have your P, you have your I, and you're asked to find N. How would you exactly do that? So you basically need to know your logarithms, and this is what I mean by that. So we basically have, let's call A in this case, just so we have a basic description of what I'm about to do. So let's say A is Y in this case, and P, all of this basically is just X, which is that indicated by that. And you have that same N over there. Now let's say you have Y and you have X, and you also find N. How would you exactly do that? So to do that, you just say your exponent is equals to the log of your answer to the base of your base. So this is the base, this would be your answer, and this would be your power or exponent. So the exponent is equals to the log of your answer according to the base of the same base which is used in this exponential term. So this is how you'd find your n. Now in terms of finance, an example, let's say you had something like 2.21 is equals to 1 plus 0.12 to the power n. Now applying the same thing, this is just an example with just basic values. Applying the same thing, you just say n is equals to the log of your answer, right? Which in our case is 2.21. And using the base, which is the base of that exponent still, right? This is how you basically do it. You can just punch this into your calculator to find the value of n. So that is one thing which I wanted to talk about, and we're also going to do an example on this or something like that. And the last thing which I want to talk about before we do examples is nominal. If this thing would just write nominal and effective interest rates. Now, the difference between these two is your nominal will be what's stated in the question, right? So your interest rate per annum, which is basically stated in the question, and your effective interest rate would be the actual rate which is used when we actually consider compounding periods, right? So we're talking about compounding periods, and you can immediately see that we're actually talking about compound interest. That is what we're talking about here. And so this is going to make much more sense when I do an example, but basically just know that your nominal is your interest rate per annum, which is stated in the question, and your effective basically now is that interest rate, but considering the compounding periods. And you have a formula to actually switch between the two, and it says this, where I sub EFF is your effective interest rate. So this would be your effective interest rate, and that is equals to 1 plus I sub norm divided by m to the power m. And your m would be your compounding period, which is the same one as that one over there. and your INOM would be your nominal interest rate, and this is just 1 over here, and here you have your effective interest rate, and this is also just 1. So you can basically swap between the two by using this formula given here, and I think I have an example for that. So now let's move on to the next page where we start with examples. Okay, so let's scroll up so that we actually start at the first example that we have. Here it is. It says calculate the value of an investment of 10,000 rand that earns simple interest. So let's just mark that simple interest of 9.8% per annum over 5 years. And the second one says 6.75% per annum over 6 months. So it said simple interest. So we basically, and it's an investment, we expect that to grow. So we're basically trying to grow this 10,000 rands over there. So the first part of the question, we're just going to write our formula. Always write your formula. I think there are marks for that. This is a simple interest formula. And we want to find the value of this 10,000 rand, which means that in 5 years, if it were, so this is the first part of the question. Now, since we're given the amount, and that is the amount which you're actually investing, then that would be your principal value. And the value which we want to calculate, or the amount which we want to calculate in 5 years, is your accumulated. So we don't know that value. So you can say 1 plus, and this is a percentage. So you have to transform it into a decimal, or just put it in the form of a fraction divided by 100. And your n would be 5 years, right? So all that you have to do for this question, just basically substitute the interest that you have, as well as the number of years, and finally your principal value, which is your original value which you put into the investment. Now, putting this into your calculator should give you the answer after 5 years, and that answer should be 14,900 rands. So this is your answer. If you put 10,000 rands into a plan which offers 9.8% per annum over 5 years, this is what you expect to get back. So if you answered that part of the question, the next question, or the next part of the question, that same question, using that same 10,000 rands, now we basically want to find, using the same formula, basically want to find what this plan would give us. So if we are given 6.75% per annum over 6 months, how much would we have after 6 months? That is what the question is asking for. And if you remember from our description of the formula, you have your principal over there, which is what you put in the investment. You have 1 plus, then your interest rate in this case would be 6.75 divided by 100. And n would be your number of years, but now we're told this is for 6 months, or the investment only lasts for 6 months. And 6 months is half of a year. Since n is known to us as a year, then we put a half over there. And that is to indicate that we are actually talking about half a year. If it was only a year, just put 1, but now it's 6 months, and 6 months is half of a year, and that is why we have that half over there. Putting this into your calculator should give you 10,337.50 cents. Right? So that is what we have for the first question. It was just a simple interest question. And we're going to move on to the next one. The next one says a man wants to make an investment that will be worth 50,000 rands after 10 years. So let's take note of this. It will be, which means this is something which is gonna happen in the future. So will be worth 50,000 rands after 10 years. So already know that our n is 10 years. We already expect our accumulated value to be 50,000 rands. What amount must he invest now if the interest is calculated at 12% per annum compounded annually? Okay, so this value is compounded annually, and that basically means that we can just use the years because it's per annum and compounded annually. We don't pay, or it doesn't earn interest more than once in a year, so it only earns interest once in a year. So for that, we just basically use a compound interest formula where your n would be the number of years. Our expected accumulated value is 50,000 rands. So we want to find this P, we want to find the amount that he must invest now, right? So that he get that 50,000 rand return in 10 years. So the I is given to us as 12%. So you're going to have 12 divided by 100. And then we're going to put this n, which is the number of years, 10 as our exponent. And just doing some basic math manipulation, you're going to have P equals to 50,000 divided by everything in the bracket to the power 10, right? And the answer which you should get, which is your principal amount, the amount which you must invest now to get 50,000 rand in the future, is 16,000 rand, 16,098.66 cents. So that is what we expect. That is what he must invest now so that he has a return of 50,000 rands in 10 years. That is the second question. Moving on to the third question. It says you win, what's this? You win 500,000 rands in the lotto and want to invest the money wisely for the next 5 years, right? Okay, so we won something, we have it now, and that is the amount that we have now. And we want to invest the money wisely for the next 5 years. Okay. The following options are available. Bank A offers 11.1% interest per annum compounded quarterly. Bank B offers 10.8% interest per annum compounded monthly. Okay, so this is quite interesting. The first one offers an interest rate per annum compounded quarterly. The second one is 10.8% per annum compounded monthly. We can't exactly compare, or we can't exactly see what the returns of each of these are just by reading. So you shouldn't just look at this value and say it's bigger than that one, and therefore the first investment would actually give you a greater return. That would be a mistake on your part. So you actually have to do calculations as the question says. As the question says, it says show the calculations needed to decide which is the best option. Okay. So we are dealing with compound interest, but the compounding periods are different. So that same formula can also work in this way. Now, if you look at this formula, we are interested, or we can also say that this n is an indication of the number of times that the amount is compounded. So number of times amount is compounded. And this comes into play if you're told about a different compounding period, which is, so if it doesn't just end here at 11.1% per annum, and you actually have a compounding period just like there, you actually have to translate your I, so you translate your I and your N into the number of times that the compounding is going to take place, right? So this investment is over 5 years, as we saw in the question, it's over 5 years. And the compounding period for the first one, so let's compute what Bank A will give us after 5 years. So your A is equal to the principal amount of 500,000 rands multiplied by 1 plus, then you have 11.1%, which can be transformed into 0.111. Now we divide this 0.111 by the compounding period. So it says quarterly, and there are 4 quarters in a year, right? So per annum, compounded quarterly. In a year, there are 4 quarters, and then you're going to divide that by 4, and you're going to close the bracket, and your exponent, we are dealing with 5 years. Okay, that is fine. But in that 5 years, this is going to be compounded 4 times because you have 4 quarters in a year. So you multiply that by 4. That is what you basically have over there. And this computation is what the first bank is going to offer you. So if you do that, you're going to get 864,409.86 cents. So that is what we're going to have, or that is the value which bank A is going to give us. And we're going to move on to bank B. Let's check bank B so that we can finally compare. So for investment, we want the option that will give us more money, because we're investing our money, putting it away for some time and not having access to it just so it grows. So the aim of that action is to grow the money. So they're actually going to see which one is going to give us greater returns and choose that option. So now for the second part of for bank B, it actually offers 10.8% interest per annum compounded monthly, and we have 12 months in a year. So if we take that into account, you have 500,000 rands, you have 1 plus, and then this I, which is 10.8, can be translated into that just by divided by 100. Then after dividing by 100, you basically divide by the compounding period, which is 12. You have 12 months in a year, so it's monthly as indicated over there. Then in those 5 years, this will actually be compounded 12 times. So you have to multiply the number of years by the compounding period. And the answer you get here should be what bank B offers. And that amount should be 855,933.41 cents. So these are the two amounts that we have from bank A and bank B. Now, all that's left is to choose one. As you can see, this one is actually greater and it's from bank A. Therefore, bank A is a better option. So make sure that after doing all these calculations, I know it's obvious, but after doing these calculations, just make sure that you state which option is better, right? Moving on to do more examples, I think I have a few more examples here. So this is question 4, example 4, which I believe is probably the last example before I talk about a few more things. We're told that we should calculate the nominal interest rate if the effective interest rate is 15% while interest is compounded quarterly. So let's look at that. Let's see what that looks like. So we're dealing with nominal and effective interest rate. And I mentioned that we have a formula which can help you to swap between the two. And for this question, we are explicitly asked to find the nominal interest rate. That is what the question says. So we're just going to do some mathematical manipulation to actually have I nominal isolated so we can have everything else give its value. So let's substitute the values that we do have. So we're told that we have 15%, which is your 15% compounded quarterly, which should be your effective, as it, if you remember my definition, it actually includes or it considers the compounding period. So that should be your effective rate. And that is equals to 1 plus I nominal, which we want to find, divided by a compounding period, which is, so it's quarterly over there. So expect that to be 4 quarters in a year. And now all that's left is to actually find I nominal. And to do that, just find this on both sides. And adding these two, you're basically just going to get 1.15, just so it's compact when we're writing. On this side, the exponents are just going to cancel out if you find the fourth root or whatever this is actually called. So that is that. And you can say I nominal divided by 4 is equals to this, right? So I just basically took this to the other side and then you just swapped, took this, basically it should be on this side, I know, but I just wrote it on this side because the stuff is equal. So I just took the 1 to the other side of the equal sign and you should get that. And your I nominal will therefore be 4 multiplied by the fourth root or whatever that is called, subtract 1. And you just have to put this into your calculator and you'll actually get your value for I nominal, which should be 0.142. And in terms of percentages, that this would be 40.2%. So lo and behold, we've actually solved that problem. And you basically just have to do the same thing for the next one. So I'm going to give the next one to you as homework, and you should get a final answer of 12.7%. So I'm just going to leave the question here for a few seconds just so you get the question. So the second one says 13.5% while interest is compounded monthly, right? So the answer you should get for that is 12.7%. Now that is all in terms of examples. I just want to talk about a few terms which are quite important. And the first one is a sinking fund. Right? Let's say you have a car. Let's draw a terrible picture of a car. I can actually draw just that. Yeah. So let's say you have a car, you bought it today, and you plan on selling it in 5 years. Now, this car will definitely depreciate, and you'd use this formula to find its depreciation. So you'd find how much it's worth. If you paid a certain amount to buy a brand new car, that would be your price for a brand new car, BOP. Then it would depreciate. So no, it's actually should be compounding. It's mostly done this way. So it should depreciate, and after depreciating, you'll have a certain value. So let's say you bought a car for X amount, and after 5 years, when you want to sell it, it is worth 200,000 rands. And the new car that you want to buy is 600,000 rands. So the difference between the new car that you want to buy or the new piece of equipment, it can be anything. The difference between these two is your sinking fund. So you want to replace something, you're going to have its value after a certain number of years, then you're going to have the value of a new one. Now, if you subtract the value of the old from the new, then the amount that you need to actually make is called your sinking fund. Now, if you take this sinking fund, so in this case, our sinking fund would be 400,000 rands. And that is the amount which you have to raise, or that is the amount which you have to find some way to satisfy this purchase of this new item after selling your old item. So once again, you're gonna have the price of the new item, and you're gonna subtract the price of your old item after selling it after a certain number of years, and that would be your sinking fund. So that is a sinking fund. Now, when we talk about the reducing balance, we are talking about this depreciation over here. So this depreciation, the formula that you'd use to calculate the value of your car after a certain number of years. So you put the price of a brand new car over here, and it would actually decrease or depreciate over time using this formula, and that is called your reducing balance. Another term which I want to talk about, which is the last term, would be your scrap value. Now, your scrap value would be the actual amount that you get after selling your old item. So the amount that you get after selling your old item is called the scrap value, but the method that you use to calculate that scrap value is called the reducing balance. So the reducing balance is the method itself, and your scrap value is the amount which you get after depreciating. So that is all that I wanted to talk about in this video. And if you haven't subscribed, please subscribe. If you like this video, just go ahead and give it a thumbs up. If anything, absolutely anything isn't clear, just leave a comment. And I'll see you guys in the next video. I should make more videos on finance because I haven't covered loans, I haven't covered annuities and all those things. So I'll see you guys in the next video.